Hello everyone, this is lecture 14 of advanced drilling, PTRE 451, 545. We didn't have a class last Thursday. We have class today on Thursday. Your homework is due on Friday, and homework 3. And then we come back, we have 1 day for review after spring break, and then this exam. So, and after that, we have to worry, or intermediate of that, there is a little bit of an overlap, I think, is we have to worry about the first phase of the project. So, some announcements to start with. I shifted my office hours today from 12 to 3 instead of 1 to 4 because I want the extra hour. I have some deadlines next week actually to submit some stuff. And I had deadlines last night with the ATCE abstracts and stuff. And I had to deal with 6 of them. So it was ridiculous. So today it's still 3 hours.
You submitted 6 abstracts?
Yeah.
Wow.
Thanks. Yeah.
Yeah, if 6 all this is accept.
No, for 1 or 2 to be accepted. I mean,
yeah, but you are supposed to submit, you have a maximum of 3, right?
Yeah, but if you are smart, before you make your last submission, you open another window and you press new, and you have the window for the next submission open while you make the 3rd submission, so you get the chance to submit 4 and then 2 from other students.
Okay. Yeah, I submitted 2 yesterday, and I was waiting for my advisor to send the correction, and then when he sent it, and when I checked, was 3 minutes to the time.
Yeah.
And I quickly opened the window. He told me before, I quickly opened the window, then you can have access to now be submitting.
Yeah, you have access for a few hours later.
Yeah, even hour. I never knew. So when I was submitting, I said, okay, it's a smart move, man.
Yeah.
Whether you have opened it down.
Yeah, so even if the deadline kind of you open it still.
If you have submitted 3, it doesn't let you press new.
Yeah.
That new button is gone. So you need to press new, get the new window open, and then make the 3rd submission.
Yeah.
So you have the chance for 4th. By the way. Yeah, so we have the homework due. By the way, Kalu has an exam tomorrow, I think, the TA, so he won't have the homework tools until after. But I gave you guys the solution key for homework 2.
Yes, already.
Already.
Yeah, I saw something.
So you don't, but you're gonna get your grades soon. Depending on Kalu's schedule, I think he rushed to finish the other class homeworks because there was an exam in that class yesterday. Then homework 3 will be due on Friday. I will go over it today, and on Thursday you guys still have issues, but it shouldn't be too much of a problem. What else?
Demand a lot of thinking.
No, homework 3 is not that.
Yeah, a lot of thinking.
You did homework 3?
Yeah, you didn't know this one. Yeah, we are still on it, but
Yeah.
I'm still on it, but a lot of thinking.
Not really. I mean,
a lot of thinking.
but it's gonna become clearer after today.
Okay.
That's for sure. What else? Oh yeah. I want you to pair up students who are. I want you to get in pairs, right, with somebody from your class, and so that you for the project, and basically you can get into groups of 2 as long as you are in the same class, as in either you're undergrad, you get with an undergrad, PTRE 451. If you are graduate, you are PTRE 454. So you get to a pair with somebody from 545. And this is for the project.
Okay.
Yeah, a pair with 2 people.
Okay.
2 people, yeah.
Okay, not more than 2.
Yeah, I have let, and you need to get like the iPhone app onto one of you needs to have. And you can decide how you want. You can give, one can give the other one $25, or to half off or to
Just better. I
Well, the government
I
now-
collect $50 from the president.
I have
You pay now.
I have let people work on their own before if they wanted to. That's fine if you want to work on your own, but for pairs is a little bit better.
Yeah.
And because some people may not have an iPhone or an iPad, etc., etc. Anyway, so pair up. Send your pair to Kalu and copy me. Send your team basically to the TA and copy me. The TA will put a nice spreadsheet together. And at some point, we can share it on Blackboard to see who's still available or not. The thing is, I want you to be in pairs before spring break, if I can, because during spring break, I will write the project. And then I will, if I do it early, I haven't decided what I will do on spring break because I have deadlines during spring break. I will post it. I want to post it as early as possible to give you guys more time. Because I know on spring break you'll also be studying for the exam,
Yeah.
Uh,
Yes, studying for exams,
yeah,
for the test.
I shifted everything 1 week later. So ideally, this exam would have been this week, but it would have been crazy. We couldn't do it without, I want to do homework 3 before we do the exam. And well, the semester started 1 week later, so I couldn't. Ideally, it would have been during spring break. That week would have been the exam. But yeah, it's that's how things come. I don't want to, because homework 4 and 5, more like homework 5. Homework 5 is hard. Homework 4 is easy. But the projects are gonna be, it's not time consuming, but it's gonna be quite intensive. And I want to give as much time for those intensive stuff, project part B, homework 5, which is the last homework of the class, and ahead of the final. I want to give us as much time as we can for that. So yeah, I don't want to allocate too much time on easy stuff because the easy stuff would be done. It's the hard stuff that I'm more worried about. So yeah, send Kalu your pair, your team basically, and what class you are taking. You guys are taking 545. The online people, Donald is taking 451. Justin, I think, is taking 545. Yeah, make sure that who you pair up is with your own team. If there is any problems, let me know. Once you get the app, also if you have problems with the app, let me know. Don't ask the TA because I'm not sure if the TA has the app. So for app-related problems, probably you're gonna be coming to me for technical issues. You can either go to me or Kanu. Yeah. Anyway, so homework number 3. If you go to Blackboard and you come to learning modules, you'll find homework number 1, homework number 2, the solution key is there. Homework number 3 doesn't have a solution key yet because it's still due. Let me pull up the solution key I gave to Kanu, so I know what I'm talking about. There you go. So, homework number 3. Background. Before tripping out for a new beat, a total pressure drop flow rate test was performed. The mass density is 12 ppg, and there are 3 jet nozzles on the beat with 13/38-inch diameter each. The following total pressure drop flow rate was obtained. 400 becomes 2310, 450 becomes 2870. 500 becomes 3485. 550 GPM becomes 4155 PSI. Section A, maximizing the hydraulic horsepower at the bit. Assuming all components of the circulating system are in turbulent flow for the next bit run, maximize the hydraulic horsepower on the bit output if the pump discharge pressure is fixed at 4,000 psi. Use curve fitting in Excel or any other program you like to calculate the K and N parameters of the aerological model of the mat. If delta Px, that's the frictional losses, is equal to K, should be capital K, Qn. Determine the values for delta Px, delta Pbit, Q, and A. See question 2 for their definition. That's question number 1, okay. Question number 2 for 15 points. What size jet nozzles you will install on the new bit if the pressure drop across the bit nozzles is given by this equation here, which you can also find in the book. Where Q is the flow rate in GPM, gallons per minute, rho is the mass density in ppg, T is the nozzle coefficient, usually 0.95, and A is the jet nozzle area. So how are we gonna go about solving part A, section A? So we have data, sorry. Look at the data that we have here. Okay, this is good to have it. We have GPM, basically this is Q. This is total pump delta P total. Okay. One second. Yeah, that's correct. What did I do wrong? Okay, oh, that's fine. Okay, so how can you plot this data such that you get this and this? Do you think? You can linearize this equation in a way that you can build it as a straight line, right?
Yeah.
Okay. So you are gonna ln both sides and get something that is in the form of y equals mx plus c, right? Okay. And then you're gonna measure the slope and the gradient, and you will have basically n. You want to get n, and you want to get k. Okay. Capital K. This is basically capital K. Okay. So once you get that, you're basically gonna use And basically you need to basically plot it and show me the lines and everything. That's fine. Once you get it, you can basically use the equations that we learned from class to give me these values. And
Those values, are they the optimized
the
values?
optimized, yeah.
It was not, that's why I just want to be sure.
You know how you find the optimized delta P, those fractions that we said, n divided by n plus 1, blah, blah, blah. Those are the equations that you have to use. The sequence that you are going to use it is you are going to find delta px. This is going to be the first one. This is going to be the second one. This is going to be the third one. And this is going to be the last one. And I want the last one basically in once you find A, and you basically you can divide A by 3 because there are 3 nozzles, and then you do the diameter of the nozzles. But I want you to give me the diameter of the nozzles in 30 seconds of an inch, right? When you get the diameter of the nozzle, you are going to get the value 0 point whatever. I want you to convert that to 30 seconds of an inch. And it should be like a solid value, like 10 out of 32 or 15 out of 32. That about, oh yeah, sorry, there is another question. Oh yeah, that's question number 2. Yeah, we said that. So basically for question number 2, size of jet nozzles. You have A from here, and you include it here. Yeah, you may be able to use this. You can also use this equation in question number 1 if you want as well. So it's a universally applicable sort of equation for this kind of fluids. You're not universally applicable, shouldn't say that, but yeah, it's because it's in the book available to use it.
So can I ask a
Yeah,
question
of
now,
course.
number 1? Are we going to plot the total pressure discharge versus the Q? Or is it just the delta PX?
What do you mean?
Like this delta PS, is it the same thing as the delta P total there?
That's the delta P total, it's not the
It's
same.
not the same. So we still need to calculate the delta PS.
Yeah, but you are given something there, some information, useful information there. The discharge pressure is limited to 40,000. Yeah, well, that's important. And you cannot exceed that value. Let me see.
So
Yeah.
does it mean that when you get the bid, when you calculate and get the bid optimum, the optimum bid,
Yeah.
now you're going to now probably look at subtracting that from the total.
Yeah, that's how I will show you how you get the bit.
Total descent, so that you can get the delta X.
No, we know how to get the. Remember these equations? Look at the bottom. Yeah.
That is delta P bit.
And at that point, you know n from the plot, right?
Okay.
You know n from the plot. There is another one that I want you to know. That is important. Oh, I think we passed it. Is it here? Well, this here where my mouse is important, but ultimately, you know that delta P total is equal to delta Px plus delta P bit,
Yeah.
right?
Mhm.
Okay,
Now, okay.
but think about it. When you are doing a total, when you are doing a total pressure, when you do the, yeah, to avoid confusions, when you do a total pressure drop flow rate test, where is the bit?
When you're doing what?
This test,
Uh-huh.
where is the bit? These values were obtained during a test. Where was the bit?
Yes. The bit will be at the bottom.
You're standing up. Like, remember, you are not touching the button unless you are rotating.
Yeah.
You are not rotating when you are doing the bit.
Above the bottom.
So these values that are total, what are they equal to?
Okay. We can say they are equal to the total pressure losses over at during the test at the down.
Yeah.
Yeah.
It's like what I did in the. It's like what I did in the simulator, the first video that I showed you guys. It's the pressure losses in the system, but am I drilling at that time? Am I rotating?
No.
No. Yeah. So
They should be.
delta P total is equal to what?
If you are not rotating, then it should be equal to the hydrostatic.
No, easier. Delta P total is delta Px plus delta P bit. What is the delta P bit now?
Delta
0.
no. No zero now.
If you are not rotating.
I'm not making a hole.
Yeah.
Yeah. I will. I have the numbers here. I don't have the actual
Was during
results, but
delta P bit. So which means that when we get a delta P bit, now we can subtract from the delta P total and get a what? Delta
Px.
yeah. Delta P total minus delta P bit is equal to delta Px.
Like that equation that you showed us. Okay.
Yeah. The delta P and the horsepower is the same thing, right? You add them up. Sorry, I got confused myself as well. Tonight in the office hours, I'm gonna check the spreadsheet and make sure. If I made a mistake, I will send an announcement on the blackboard.
Yeah.
But it should be easy. Yeah? Linearize this equation, get the N, get the K, and then plug those equations on the PowerPoint to get the delta P bit. Once you get the delta P bit, you subtract that from the
4,000.
Yeah. And then you get the delta Px. So you have delta Px, delta P bit. Now Q and A, you will have to basically, since you have delta P bit from here,
Yeah.
you can use this equation. Maybe I should have moved this equation higher up. It would have been easier.
Yeah. So that it won't be confusion. You
Confusing.
know very well
that
that one you're gonna use that one.
Stupid mistake I made. Yeah. And then C, you know C, right? 0.95 is not a problem. Rho, you know rho is 12 ppg, I think. I saw it earlier.
And the Q is
Yeah. And
flow,
then basically,
the flow per each flow.
yeah. And then once you get you have basically, you have to find Q, and you are given A in this case, right?
Yeah.
I think it was yeah, 13 over 32. So you can find A, then you find Q. And then for question number 2, you solve for A. You divide A by 3, and then you convert that to pi d square divided by 4, and you get and then you multiply by 32 to get that. So this is how this question is done. And yeah, it's the third time I'm giving this homework, and I forgot about I didn't check it last night. I should have checked it. Assuming all components for part B, now we're trying to maximize the jet impact force at the bit. Assuming all components of the circulating system are in turbulent flow for the next bit run, maximize the jet impact force output at the bit if the pump discharge pressure is limited, fixed at the 4,000 psi. That's the delta P total, by the way. Use the same rheological parameters for MAT with section A. What actual jet nozzle sizes would you install in the new bit to maximize the jet impact force? Okay, question number 3, how are we gonna do that? You will use basically the equations from the class, from the lectures, I mean, the slides. You are gonna find the Q optimized. Then you will find the A optimized. Let's see. Where is there you go. You have K, you have N, you have delta P total. You are gonna find the Q optimized. Then from that, you can get the A optimized. And then you divide by 3 and you convert to diameter of the nozzles, right? It's fairly easy. Question number 4. Comparing one table the values of a system pressure drop, pit pressure drop, flow rate, and jet nozzle area for maximizing hydraulic horsepower at the bit and jet impact force on the bit output. So let's see. This is just a table. This is delta Px. This is delta P bit. This is Q. This is basically A. And you're gonna do basically 2 columns, right? 1, 2, 3, 4. So 1, 2. You're gonna do HP bit max or impact force max. And then you give me basically, yeah, those 4, like you give me Q, sorry, let's do it in the same sequence. The sequence is basically how you do it. Delta P bit, Q A, and then basically, that's all I need here. Nothing fancy. You already have it basically. This is the points there. Question number 5. What approach yields the highest equivalent circulating density and why? Okay, you need to think about that. What will yield the highest ECD? What is the ECD equation? It's gonna be ECD is the static plus the losses, frictional losses on the annulus divided by 0.052 times the TVD on the bit. Okay. Okay, everything you know, everything is the same except one thing. What is the one thing that is different?
Everything is what?
Everything you know is the same. Everything is the same, right? ECD is the static mat weight, which is 12 for you guys, plus delta P losses in the annulus divided by 0.052 TVD bit. Okay. Is this the same for both?
Yes.
Is this the same for both?
Yes.
Is this the same for both?
No.
Okay, so that is the different one. That is what is different. You need to tell me which column of the table will impact this the most. Okay,
I think if you look at even the parameter, you will now see which one gives the higher distance. After as you compare the table.
well,
Yeah. Always.
this depends on what?
Yeah, pressure drop in the annulus. It depends on the frictional drop in the annulus.
Which depends on what?
It depends on the length of the drill pipe, the length of the.
They stay the same. They are the same for
That's
both.
the same for
cases.
both. Then it should depend on the rate now.
Oh, the rate. What is the rate in our calculations?
For the two
Yeah, what is the symbol that is related to that?
GPM.
Yeah, what is the symbol? Our symbol in the equations. In those four things.
Q.
Yeah.
Q.
Okay. This is how you need to think about it, basically. And explain why. Easy. Question number 6, what might be some implications of question 5 on ROP, low circulation, leak off, fracture pressure, and overall pressure control? Okay, this is now a broad drilling question. If I have high ECD, what does that do to my ROP? What does that do to in terms of low circulation? What does that do in fracture pressure and overall pressure control? Basically, think about the mud windows and this kind of stuff. If I have a higher, not higher ECD necessarily, but basically the two ways I optimize the bit hydraulics, how would that affect my ROP? Which one will give the highest ROP? Or maximizing the hydraulic horsepower on the bit, or maximizing the impact force on the bit? Which one will yield the highest low circulation? Which one will yield the fracture pressure? What can you say about that? Overall pressure control in general. I'm asking this question because this is the general question. This is why you do rig hydraulics optimization. These are ultimately the parameters that you need to control. Impact. All right. Any questions on the homework? It should be easy. Once you get the K and the N, I think we should be good. And you have another chance to ask me questions on Thursday and office hours today. So plenty of opportunity. Okay. So if there is no questions, we'll proceed with where we finished last time. We saw these equations, right? Last time?
Yeah.
Okay.
Calculation.
We saw this, which was very, very broad. And we were ready to talk about making a connection. We talked about mechanical specific energy, but we talk about it only as an optimization parameter or a target parameter. We want to get this as small as possible. That means we need to use as least amount of energy as we can for removing 1 pound mass of rock. And at the same time, we need to maximize the ROP. Now, in this case, these are basically parameters that we target. Okay, now we're going to talk about making a connection. And the undergrads would remember I spent a lot of time on that on the first class, and it wasn't even comprehensively addressed as well because you have a different rig, it's a different kind of connection. Connections in general are different in the Kelly rig versus the top drive rig, but they're an important thing because when you do a connection, you lose mud. if you are using oil-based mud, you need to make it up. So you buy this amount of mud because generally you lease the oil-based mud, and the mud that you don't return, you have to basically buy it. So there is another incentive to make the number of connections less, make them as quick and as safe as possible, because there is people losing their fingers or eyes, eyeballs, or whatever during making a connection. You don't want to have these kind of issues. So you understand that it's a big topic, connection. Also, it's a non-productive time. The time that you take to make a connection, it's lost time from drilling. So you add a drill pipe to the drill string. During drilling, the crew places a joint of drill pipe in a shed called the mouse hole located near the rotary table. You know that now. The driller engages the drawworks to hoist the drill string to the first joint of drill pipe under the Kelly. The crew puts the slips in place, and at that point, when you have the slips in, the reading of weight on the bill will be 0. That's how you know the slips are on. And the Kelly can be unscrewed, basically reversed, since the drill string is supported by the rotary table. Mud circulation is stopped, and the crew screws the Kelly to the box end of the joint of the drill pipe in the mouse hole. The pipe is screwed and made up in the mouse hole. I told you guys last time what is the box end, is the thick end of the tool joint. And the thin end that goes in is basically the pin. So the box and the pin, remember? We said that. Let me show you very quickly. This is the box end. And what goes in? Is the pin. This is the pin. This is the box. Okay? I think I drew something similar last time. The driller hoists the Kelly and drill pipe with the drawworks. Once the new joint of drill pipe, which is 30 feet, has been screwed and made up on the drill string, the driller resumes drilling fluid circulation. The crew places the Kelly bushing back in the rotary table, and the drilling can be resumed. This is how it looks like. This is, let me show you something. So when you lift you have a rack full of drill pipes, and you are picking up one to be placed in the mouse hole. This is the mouse hole, right? Right, okay. So when you pick up the rack, the pipe to put it in the mouse hole, you go through, what do you go through? What's the rig? You go through the window.
Window, yeah.
Yeah, what is the key to the window?
That's no key.
Yeah. Yeah, it goes through the window. Then it goes through the mouse hole, and then you are gonna basically put the slips here, unscrew. When you have the slips here, this won't fall.
To hold the pipe.
Yeah. So you can unscrew here and move this here, and it's okay because you have the slips on. Let me clear out, I made a mess. And basically, yeah, there you go. You pick it up from the mouse hole, you stab it on the old drill pipe, the one that is hanging above the slips, and then you start drilling. You start circulating and then drilling. you're gonna lose mud. It's inevitable. You're gonna lose mud in the process, but you want to make it as short time as possible. You lower a single. Single is basically a joint. Okay, single. Stand, also called treble, is basically the triple one that has three joints. One stand is basically three. Now I have told you about that rig that they made experimental to have four, so 120 feet. You understand why they tried to do that, to save time and money. What was the motivation behind it? You lower a single joint in the mouse hole, you bring a single from the rack. Now the rack and the pipe rack is a little bit of a different thing. The pipe rack, sorry, the rack here is next to the rig. Like it's not on the rig floor, and normally it's in a place where nobody can go, or it's a regulated place. You're not gonna walk there without permission or stuff. And because they lift up through the catwalk, through the window into the rig floor, and then they place it in the mouse hole. And then you're gonna pick it from the mouse hole with the Kelly and bring it to the other the joint that is above the box that is above the drill pipe, the slips, sorry, and you will start rotating. Stabbing is basically is a term used for, how does the energy glossary define stabbing necessarily? Is when you basically make the, let me see, if you go to SLB energy glossary, back in my day it was the Schlumberger oilfield dictionary, energy glossary. I want to give you the right definition. Stabbing can mean a lot of stuff, you know. To place the male threads of a piece of the drill string, such as joint or drill pipe, into a mating female threads prior to making it tight. Male is the box. Sorry, male is the pin. Female is the box. Then you can understand why. To guide and engage. Yeah, that's correct. That's correct. Anyway, now round trip. What does a round trip mean? It means that I'm removing all the pipe from the well. Maybe I want to change a bit. We call that trip TFNB, trip for new bit. This is how it's going to show the report. We trip for a new bit. So the first step is to disconnect the swivel from the hook and place the Kelly and the swivel, which is still connected to the mud pumps by the hose in the rat hole. Rat hole is bigger than the mouse hole and is normally slanted. It has an angle. And this is why you put the Kelly when you are not using it. Such as in this case. The crew latches the elevator under the tool joint of the first drill pipe joint, and the driller hoists the drill string to a height of 3 joints. That's about the stand. That's as high as you can go, basically. Of pipe with the drawworks. And you have to have the guy, the derrick man on the derrick at that stage, because he will handle the top of the drill pipe. The fourth length of drill pipe is clamped in the rotary table by the slips. That's the one that is left behind. And the connection is unscrewed with the tongs. A stand of 3 lengths of pipe is then hanging from the elevator. The crew pushes the lower end of the stand so that it rests on the setback. Then the derrick man who stands on the monkey board unlatches the elevator, holds the stand, and places the upper end of the stand on the pipe rack, and they number it. Every stand that comes out of the hole, you number it so that you connect it. If number 58 was connected to number 59, you want, when you go back, to connect again number 58 to number 59. Because there is also a lot of stress applied in the process. When there is stress applied, there is deformation happening. So there is threads that are crossed and stuff. If a pair matches, you want to keep it like that. Okay. The operation continues down to the drill collars that are also stacked vertically in threes, stands basically. During a round trip, both rotation and circulation are at a standstill. You don't circulate, you don't rotate. If either is needed, the Kelly is taken out of the rack hole and screwed back onto the drill string. Remember, you cannot have rotation without the Kelly, right? It's the square thing that rotates, or hexagon. So you don't have it, if it's on the rat hole, you are not rotating. And if you are not pumping, you are not circulating either. There you go. This is, you see the A is the rat hole, you understand that there is an angle, and it's also thicker than the mouse hole because rats are bigger than mice. Sorry, pipe rack, also fingerboard is another name, where the one that stands, this one. Right? That's the one that I told you that you have to be careful. Moving it is like a sail of a ship. If there is high wind, you need to move it a certain way so it doesn't have, its smaller side is towards the wind. So if you have the bigger side towards the wind, it's going to create a big force that rotates it can really bend the rig down. You need to be very, very, very careful with this stuff. So when do you stop drilling? When do you stop drilling, Rock?
When you are going to change a new.
Okay. Any other time that you want to stop drilling? What you said is not wrong. Just looking for something else.
Casing points.
That's a good point, but even better. Like when you TD it, you made it to the end, right? You reach the target zone. Sometimes, well, back in the vertical well time, you will go a little bit lower than the target zone, right? That extra part, you know what it was called?
Or you mean if the target zone is here and then you go
A little bit deeper. Do you know what was that extra part called? Rat hole. Again.
yeah.
So it's, the style is confusing.
Okay.
Yeah. If you have differential sticky, then you cannot drill anymore. That's not a good time. So you cannot rotate. If you experience low circulation, yeah, mud losses, yeah. Anything out of the ordinary taking place, or if you reach if you have drilled the section that you are planning to drill, basically, and you want to set casing and cement, or if you are, what did you say that you want to ask you?
Yeah, if you want to change a new
bit? Yeah, any of those times you stop drilling. There is another one though. Indication that you are taking a kick. That's an important one. Okay, because when you are drilling, you have your eyes open for this kind of thing. Okay. What is taking a kick? And you already know this. I mean, we have gone through that, but I guess we have to do it officially. Flow of rock formation fluids into the wellbore during drilling operations is taking a kick, right? A kick is physically caused by the pressure in the wellbore being less than that of the rock formation fluids, therefore triggering fluid flow from the rock into the wellbore.
Yeah.
Okay, that's a kick. If not managed correctly, you're gonna have a blowout.
Boom.
The kick volume must be circulated out of the hole, and the mud in the hole should be replaced with the new mud of appropriate density. You want a kick because you are dealing with the wrong density, right? So you have to replace that. Now, what are the kick indicators? That's very important. So, slide. So when you are driving, what are you looking at on the dashboard?
Ah, the pressure.
Oh, you're not looking at the pressure.
Blowout, pit volume.
Yeah, that's basically the gas tank. You are not really looking at it all the time.
We'll be looking at the speed.
Yeah.
Speed,
Speed.
kilometer. Speed when you're driving. So you don't exceed the speed limit.
Yeah, you look at the speed when you're driving, correct. And really, you look at the ROP. So if you suddenly get an ROP increase, it could be because you switch from a hard formation to a soft formation,
Yeah.
right? That's okay. But it could be because you want a kick. Okay, the kick helps remove rock. It's like, it looks like it helps you drill. But it's not really, you are taking a kick.
No. Someone is.
I'll give you that.
I saw someone pass over.
Yeah, if you drill and your ROP increases, it could be okay. It could be expected. But it could be because you're taking a kick, very important. We call it a drilling break. Okay. So that's one thing. Another thing is
So
the
now,
pit. Yeah, go ahead.
yeah. So how will you now know that, okay, you have gotten to a different formation, maybe that formation is weak, that is why it is doing that, or it is truly a kick that you.
Well, you're gonna see maybe later on today, but okay, you really know what you are drilling through most of the time. You know when there is a formation gonna change, but you are not always certain. Okay, it's not gonna happen when you expect it all the time. Sometimes you are drilling, you think you are drilling somewhere, but you are drilling somewhere else, or you are drilling something else. But to answer your question, it's not just one thing that you are looking at. You're looking at a lot of things at the same time, like pit gain. If you are looking at the pit volume, it's like the gas tank.
Yeah.
If you find more gas in the gas tank, something is going wrong, right?
Yeah, it means that is a lot of.
You have fluid into your well,
Yeah.
coming into your well. But suppose that you think you have a kick, and you are not sure, what are you gonna do? You're gonna stop drilling, lift the bit of the bottom, and then shut off the pumps. Okay? If you shut off the pumps and you get flow back, you will have it's an indication that you are getting a kick, right? There is an exception to that, and that is if you are drilling through a hot rock. When you stop pumping, the hot rock heats up the mud there. The mud expands and creates a flowback. It creates a flowback not because the mud was wrong density, but because it was the wrong
Formation.
no, it was the formation was hot.
Yeah.
Okay, but if you keep doing it, when it expands, what happens to the density?
Expect to decrease.
Yeah, exactly. So you will end up getting a kick maybe eventually. So it's not that it's a sign that you may be getting you have a kick, you don't have a kick now, but if you keep like that, you will get a kick, you know. So yeah, flow back
So in that case, so if you are drilling as a driller, you know very well that the deeper you go, the higher the temperature and pressures and those stuff. Depends on the formation. So how are you going to cater for the mat to be able to know that okay, this formation, yes, we got to this is a higher temperature and high pressure to be able to contain that.
Yeah, I mean, you have to put the right additives in the mat. If the mat, you know, you're gonna be dealing with higher temperatures. So you have to make sure that your mat can withstand these higher temperatures. Not just the mat, also the tubulars. The bead, the MWD tools on the bead, everything in the BHA must be able to withstand those temperatures. Now, flow bag, what is a flow bag? In general.
It's something flowing back.
When your fluid is
Come back to the surface.
coming back to the surface.
Okay, but you know, on the rig, I have two indicators, mat in and mat out.
Yeah.
What is gonna be my mat in this case?
So if they are all equal,
Yeah,
then it means it's good.
yeah.
But if
But I pumped it off. I turned my pumps off.
yeah, so but if it is the mark out is higher than the this and that's the flow back.
So how would that look like on my indicators?
It will be higher. Then that will, the mark out is going to be higher.
So what value do you expect the mat in to show?
So if let's say the mark N is showing 3, the other one probably
Why would it be
5.
3 in this case?
Huh?
What you are saying is not wrong, but in this case,
So in this case,
I thought I had a kick and I turned my pumps off.
So that means you're not flowing out or flowing in.
No, I'm flowing out. I'm not flowing in. I don't control what flows out, right? It's the reservoir, the king in this case. But I'm not flowing anything in. Zero GPM. What is my flow out?
Greater than 0.
Yeah. Bigger than 0 GPM, right? Okay. So I thought I had a kick. I stop pumping. And I get like, I get bigger. Now, this is not only the only thing. It's like during drilling, when I see my ROP increase, when I see my pit gain, I might also see mud in bigger than mud out before I stop pumping. Then I have 3 indicators that I'm having a kick. And I need to be worried about.
why the M is higher than the distance, the out?
Because, oh, sorry, mud out, sorry, yeah. The other way around. Sorry, I was stupid. This one, mud,
Yeah.
mud out is bigger. Yeah, sorry. Mud out, I get more out than what I put in. Okay, now if it's the other way, it's low circulation. Anyway, so these are some indicators. Let's see some other indicators. Hydrocarbon shows in the mud. I get in my mud, I get hydrocarbon. Increase of the cutting size and shape, they become bigger, noticeably bigger. Increase in the recorded trip, connection, and background gas. All the gas readings go up. Now, there no other one, but there is a problem with the first 2. The recorded trip, connection, and background gas is going to be immediate. Okay? It's going to be immediate. I will get increase in all the readings. Normally, it's just the background gas, the increase, right? But I will get, it's going to impact everything. All of them are going to be
I
high.
said for this indicator, the one that hydrocarbon, let's say oil is showing in the mouth. It depends on whether you are getting to your target zone, but if you are still far away from the target zone, where will you start getting oil showing up in the mouth?
I might be getting a kick not from the target zone. Doesn't matter.
But you are drilling, right? So you are drilling, you haven't gotten to where oil probably will be coming out from the formation.
Yeah,
Yes. So it means that that's indicator probably might not be showing at that point. I don't know whether you get my question. Like, okay, this you drill, and then you do your first casing, the second intermediate. Now you ask, but all those zones, you are not even getting closer to where oil is. Probably
Yeah.
oil, yes. So at that point, if you get a kick at that point, there's no way you will see hydrocarbon in a showing mark on the map.
but they might get a kick from, I might pass other hydrocarbon saturated zones above my target.
Yeah, I assume you haven't passed any trace of hydrocarbon.
Well, then it's not a hydrocarbon kick, it can be a water kick. But it has to be high pressure, right? Remember,
Yeah.
because the density of the fluid is one thing. The pressure of the fluid or the equivalent density of the fluid based on its pressure is a different story. I can have gas which is very light at a very high pressure, or I can have heavy oil at very low pressure, right? Now, this is for a gas kick case. Okay, hydrocarbon shows in the map an increase in cuttings, shape, size and shape. What is the problem with that is that the mud logger will notice that. And the thing is that the mud logger doesn't work with the depth that the biddies are, or the depth of the well. He works with the depth, the lag depth.
The what?
Lag depth, L-A-G. Lag depth.
Lack.
Yeah. This is the depth that the mud coming out is the depth is coming from. So I'm drilling now at 10,000 feet. But the mud coming out from the well, the cuttings coming out from the well are from 7,000 feet. I need to stop drilling and I still circulate, then I get I get higher lag depth, and then I get to the same depth as the biddies. But generally, as you are drilling, you're about 1 hour behind. That means if I'm drilling now a certain depth, 10,000 feet, my lag depth is depth I was 1 hour before, something like that. And there are correlations on how to get that. We did have a problem on that in the undergrad class, lag meters. So when you see let me show you something. Since this is important, let me go to the last class, fall of 2024. I think it was module 1. I want to show you the EDR screen. Oh, do you know who's that?
Johan?
Huh?
Which one?
Do you know who's on the picture?
Okay. That's the
It looks like Johan.
Oh, that's me. Yeah, oil-based man.
that's the mod guy. You.
Yeah, let me find I had a picture somewhere of a screen I wanted to show you guys to understand what I'm talking about. But I don't see. Oh, there you go. Okay. Okay, this is where we used to live. The trailer is basically an apartment complex. And this is how it looks like inside.
Beautiful, right?
And, yeah. Anyway, look at the EDR screen. This is the screen that everybody shares. And look at that. Let me move this. Okay. Hole depth, that's how deep the hole is. Okay. Bit depth is where the bit is standing. Notice that the bit is standing about 500 feet above the hole.
Mhm.
You know why? You know why? ROP is off, we are not drilling. Torque is high, that means we are rotating. Hook load is okay. Block height is basically how high the traveling block is. It's at 83.2 feet. That's it can go as high as 100. Where is the lag depth? Oh, there you go. This is the lag depth. Okay, this is the depth of the mud coming out of the hole where it was taken from. In this case, we have been circulating without drilling for a long time when I took this picture, and we are basically lag depth is almost the same as the hole depth. Okay, that's because the bit was standing above the hole, 500 feet above the hole, and we are just circulating in this case. But you are basically, the mud coming out of the hole is from 15,598. Now, when you are actually drilling, you are quite a bit behind, okay? You are thousands of feet behind. So yes, the mud coming out is not yet from where the bit is. So it's gonna take me a while to find this increase in cutting. It's gonna take me an hour. By the time the mud logger tells you, hey, I see some big cuttings, you have already done the damage. You already have the key. You already passed through the zone. So in real life, these are secondary indicators because they're gonna come out later. Since we are here, let me show you. Third-party gas is the background gas I was talking about. Gamma ray is from the logging while drilling tool. And azimuth, hours on the beat.
That's 24
Yeah, you have the
hours.
you have the 3 pumps. Yeah, this was a well in West Texas. Yeah.
You worked as a drill engineer?
No. I was a field geologist for a small company in Texas, in East Texas. East Texas was the company. So these observations are likely to be made by the mud logger or the geosteerer. If the mud logger will report the results to the geosteerer, the geosteerer will talk to the directional driller about it, and they will decide what to do. But it's gonna be after, okay? It's gonna be after. When you are drilling, you are really looking at the ROP, mud in, mud out, pit gate. Those are the stuff that you are looking at. And if we have time, I want to show you some videos. Let's see just one. Or we can see both.
It's good to watch video.
Well, now that you guys gonna have the, now that you guys have
Relax.
are gonna get the app, you can do the same thing. So let me show you some things on the app because you will also start using it and you need to become comfortable with it. Okay, now in this example, I'm gonna be drilling, and I will get ROP increase, but it's not or decrease, change in ROP, but not because of a kick. And I'm gonna stop and do a flowback test, even though I know there is no kick, just to make sure, and then I will proceed and then get a real kick. Okay, in this example. So, you know how I'm gonna start drilling. I increase the SPMs. I basically start circulating to 100. I increase this to 100. Then I will increase this to 60. And then I will add weight on the bit to 27. I'm reading my drill pipe pressure here. And with the, look at what I want to pause. Okay, look at the yellow line. The yellow line is basically the yellow line is the drilling rate, is the ROP, okay? The orange line is mud flow in, mud in, and then the blue line is the mud out. Okay. Look at the yellow line, it's fairly steady. At some point, it's gonna change. I'm making drill faster. So very soon, look, it decreased. It didn't increase, but it decreased. You see it? It went back, right?
The yellow line.
Yeah, the yellow line is decreasing. Now, okay, I am worried, I am concerned, even though I see my mud in is equal to mud out, 418, right? I pretend I didn't see that. Also, my active pit volume is also very good. It's also very good. I kind of know it's not a kick, but just in case, I'm gonna turn everything off.
And the pump.
Yeah, everything. Stop rotating. I go the other way. I remove weight on the beat. I remove rotation. I remove circulation, and I wait and see if I get the flow out. Okay. Now it's gonna go to 0. You see, all of them 0. That means I'm fine. I'm excellent. Okay, nothing is going wrong. So I'm gonna go back into drilling. So I will start again the other way around. First circulating, rotating, apply weight on the beat. And then when I stop drilling, I go the other way. I will keep on drilling. $100, $60, $27. So I go down to 27, 26. And I'm speeding it up. So look at the ROP. Look at the ROP now. It goes. And now I got a little bit of an increase. Which is fine. I stop again. Do you think I have a kick?
Okay, so
I don't think so, because my mud in is equal to the mud out, right?
Yes.
yeah.
So it looks okay, everything looks okay. My active pit volume is still normal.
When will you see the active volume
Going up.
to know that it is abnormal?
When you see it increasing, it's active pit volume, it decreases at a steady rate based on the hole deepening. But then if you have a kick, it's gonna start going up. You will notice it. You will notice it. So now we start drilling again. So twice I thought I had a kick and I didn't, right? I stopped pumping, I switched off everything and I didn't get a backflow, so my well is dead. That's good. Now I keep drilling again, and very soon I'm gonna get a kick. There you go. Now, you see it? Now I got a kick. Oh, sorry.
Everything increased.
Yeah, now I'm in trouble. Look at my mud out. It's 475. Look at my mud in 418. Something is going wrong. Yeah. Also, if you notice the active pit volume, it started changing.
Why?
Here. Yeah. So I stop pumping. I do the test again. I will stop. Everything turn flowing equal to 0. and stop circulating, stop rotating. Look, my mud flow in is 0. My mud flow out is 180. Now I'm sure I have a kick. So what I need to do is I need to shut in the well.
Okay.
I will basically close the blowout preventers. And how am I gonna do it? I will divert. I will basically. Did I do it or not yet?
We haven't done it.
Not yet. Yeah. Yeah. Now I'm gonna go in, set BOP, enable, close the upper pipe run, and then I will divert. Mud goes in through here and comes out. Doesn't show the casing, but I'm gonna make it come out from here. Yeah, there you go. So the way it basically, and we'll go through that in the module 4, but yeah, this is how.
That's what happened in the drilling rig.
Yeah, that's what happens on the drilling rig. But basically, when I need to follow a procedure to shut in the well, and we will go through that another time. But basically, when you hit enable, you basically turn the air on the, enable the air to go to the blowout preventers. You shut in the upper pipe run. And basically, you have to have a way for the fluid to go in and a way for the fluid to go out. You tell it, don't go out through the mud return line, which is open to the atmosphere. Go out through the choke line so that you can hold pressure. That's what you are doing by opening the choke line. That's why you close the ramp, basically you close the BOP and you make it go through
The fluid, the drilling fluid.
you make the drilling fluid coming out, not to go through the mud return line, but through the choke, so you can hold pressure. And then the choke was half open because the app has it like that. You have to go to the app, and you will see it's open at 50%. You see it's open at, on its own, it was open at, let me see. So this is the, before we get, I'm going too fast, sorry. Okay, this one, I need to. Okay, so here you can see very well. Now the current configuration, mud will flow in like this and will flow out like this to the choke, right? So you give it a way to go in and you give it a way to go out. So you are safe, otherwise you can have pressures. But the choke is half open. I don't know why they do it like this. So when you use the simulator, you have to go, you see the choke half open, 50%. That's how the game is, the simulator. So you need to, okay, I told the fluid to go there, but it's gonna be escaping because it's 50% open. So I need to turn the air on and make this 0. Make this 0. This is what I was doing, basically. You see, I was making it 0, and now I wait until they start the pressures, the DP pressure and the choke pressure start going up, and with time it will. And you see, I have a kick here. And I got a pretty tall kick. They're waiting.
Yeah.
Okay, let's go. So
to ask, I see a series of shorting,
yeah.
to test maybe have because of fear of peak. How often do that happen? Because it's
Well,
the waste time.
Here, if you're experienced, you know what you expected. There is always an experienced guy on the rig.
I will say no problem.
Yeah, but here I'm pretending
No
I didn't
problem
know.
until there's a problem one day.
Yeah, here I'm pretending I didn't know twice, so that you need to be conservative. Every time you see something that doesn't look normal, better be safe than sorry, you know? So be safe, and yeah, the first time I shut in when the ROP went down, that was very, very, it was like no acting. The second time, yeah, it was a problem, but the third time it was a
You don't want to be
problem.
confident and lose your job.
Yeah, you don't want to lose your job.
That's the way your job.
Yeah.
He said we should continue drilling.
Anyway,
People have
see you
stopped.
guys. Thank you very much. Thank you, Donald.
Are you well done?
Yeah.
Good for me. I want